right, here we are on page 4 of the packet. We're going to introduce projectile motion, which is a special type of 2D motion. This is what we're going to spend pretty much the rest of the chapter talking about. And so the two conditions for this type of 2D motion is it's got to be moving in the x direction, and the only thing acting on it is gravity. So moving in the x direction, free fall in the y direction, means I'm moving in both the x and y directions, meaning I'm going to have to list my x and I'm going to have to list my y. Now this condition that only gravity acts on it, well, that means there's only acceleration from gravity, meaning the x component of the acceleration is going to be 0, meaning I have a constant velocity in the x direction. I'm using equation number 2. The acceleration in the y direction is negative 9.8 meters per second squared. So as soon as I can identify that I have a projectile motion problem, I already know it's a 2D motion problem, list my variables, and then just that fact that only gravity is acting on it means all of this blue stuff can get filled in. All right. And so whenever we're working with projectile motion in our x direction, we're always using equation 2. Now in the y direction, maybe we're going to do a max height problem. I might use equation number 3, or maybe I'm going to have to link these two questions because they're occurring simultaneously. So they're going to have that same time. All right, so these are occurring simultaneously, so we will have the same time. So maybe I want to link these two equations, I will link them with time. Now whenever we do one of these, because we have to split it into an x and y problem, you are going to have to resolve the initial velocity into components. Now it's pretty easy if it's a horizontal launch, because all I need to do then is say that it's not moving up or down initially, so there's no vertical velocity initially, but there is a horizontal velocity initially, and it's equal to the whole velocity. If it's an angled launch, now I got to do a little trig. So I have to identify what's the angle. Is it relative to the horizontal or is it relative to the vertical? And then find those components of the initial velocity so that I can plug them into my equations. All right, so let's get into some examples on the next video, of course.